So this problem is from the D-1 worksheet. Problem 18, find the value of C that the mean value theorem predicts for the function f of x is x cubed minus x squared on 0, 1, on the interval 0, 1. So first I want to draw a little picture of what's going on. There's been a lot of confusion about the mean value theorem, and I know it seems like a lot of steps, but they're not difficult. So the mean value theorem says if I have a function, so in this case we've got a cubic, I'm going to draw it like this, on this interval 0, 1. So let's write 0 over here and 1 over here. So these would be the corresponding points on our graph. So if I connect these 2 points, this would be my line that connects those 2 points. And if I look at the slope of this line, the mean value theorem predicts that I will have a slope of a tangent line would be equal. So that's why I drew the lines parallel at some point. So this would be like our value of C. And if I think about my slope m on this line, this one right here would also have slope m. So what I need to do is I need to first find the slope of the line connecting the endpoints. So we have to be really careful. 0, 1 is not an ordered pair. Those are both x's. So I'm talking about where x is 0 all the way until where x equals 1. So in order to find those ordered pairs that are on my line, I have to do f of 0 and I have to do f of 1. So when I do f of 0, that's going to give me 0 cubed minus 0 squared, which is just 0. So if I plug in 0 for x, my y is 0. So I'm going to write it as an ordered pair. And when I plug in 1, I have 1 cubed minus 1 squared, which is also 0. So now I've got 2 ordered pairs. So this ordered pair on my line is 0, 0. This one is 1, 0. And this is not an accurate graph. This is just me drawing a random cubic looking function and then going from there. So I want to find the slope of the line connecting those 2 points. So now I'm going to do my slope formula. So slope is y minus y over x minus x. So 0 minus 0 over 1 minus 0. So my slope is 0 over 1, which just equals 0. So now if this line has a slope of 0, I know that somewhere between those 2 points, somewhere between 0 and 1, there's going to be an x value. And if I look at the slope of the line at that point, it also gives me 0. So the slope of a line at a point is my derivative. So I'm going to take my derivative. So my derivative of f is going to be 3x squared minus 2x. And then I want my derivative, I want my slope. This is my slope of the tangent line, right? Slope of tangent line, or equation for my slope of a tangent line. I want that to equal the slope of the line of the endpoint. So I want these two to be equal. So I want to make sure that f prime of x equals 0, and I want to find the x where that happens. So in order to solve for that x value, I'm going to take my derivative, the 3x squared minus 2x, and I'm making it equal to that slope I already found. In this case, it happens to be 0, but it could be 27, it could be 2/3. So I'm making my derivative equal to the slope of the endpoints, and then I'm going to solve for x. And I factor, and then I have my two x values. And then I know that I'm looking for the point between the 0 and 1. I don't want to actually use one of those endpoints. And so I am going to cross out x equals 0, and my answer is going to be x equals 2/3. So when x equals 2/3, my slope of the tangent line, so my slope at the point, is going to be equivalent to the slope of the endpoints. And so sometimes your book will take an extra step, and they'll say what this means is my derivative of 2/3, or my derivative of f at 2/3. So the slope of that tangent line at 2/3 is equal to 0. And so they're kind of putting the 2/3 here. And so they're saying like, this is where it happens. So it's going to equal 0 at the 2/3 for x. I don't think that you need to do that extra step, but it's just one of those things that I think has been confusing when you go to check your answers in the back of the book. So you can just stop at that x value for me. So hopefully that helps you out with the mean value theorem.